Okay, so labeling a typical phase diagram. You need to be able to read and interpret a phase diagram. ALEKS is using these letters to show the zones that are present on a common phase diagram. So the major things you need to recognize then, if we're looking at our phase diagram, is the lines are the boundaries between different phases or states of matter. So the first low pressure, low temperature phase that we're going to find is solids, okay? And something will remain solid under many pressure conditions at low temperature, right? So what happens if you heat up a solid? It's going to melt and form a liquid. So this area right here is the liquid area, okay? The line between the solid and liquid area, so this line here labeled B, is the interface between solid and liquid. So whenever you cross this line going from the solid zone to the liquid zone, you're melting a solid. If you cross this line in the opposite direction going from the liquid to the solid, you're freezing a liquid. Okay, this other zone down here at high temperature and low pressures is gases, okay? So again, if you cross the line between liquid and gas, and that's the direction you're going, you're boiling a liquid. If you cross the line between gas and liquid, then you're condensing the gas. So what about this line here between the solid and the gas labeled G? That is your sublimation line, okay? Going straight from the solid to the gas phase, which typically happens at lower pressures, would be sublimation. The opposite process where a gas goes to a solid is called deposition. So it's deposition of a gas into a solid. So that leaves us with these funny little dots. Okay, so let's look at the dot that's labeled F in this particular instance. That interface between solid, liquid, and gas, see, it's where those three phase boundaries converge. That is called the triple point, and the triple point is where solid, liquid, and gas phases under this particular pressure temperature conditions exist simultaneously. Okay, up at which is labeled C on here, is what's called the critical temperature. Okay, that critical point is where if you keep raising the pressure on a gas, it enters the supercritical fluid zone, which is not actually shown on this simplified phase diagram, but a supercritical fluid has properties of both the gas phase and the liquid phase, used as like a non-organic solvent for a lot of industrial applications like decaffeination, for example. Okay, so let's look at one particular problem then and see if we can work it out. Obviously, there's going to be 8 different variations of each of these questions depending on which letter it's asking about. Okay, so which point marks the highest temperature and pressure at which it's possible to determine whether a sample of pure X is a liquid or a gas? So that is going to be here where we've got our critical temperature, point C. If we go beyond point C, what this diagram is not actually showing you is you're entering that supercritical fluid area of the phase diagram where you can't tell the difference between liquid or gas because it's actually a different phase of matter. Along which line would a sample of pure X be a mixture of solid and liquid? So that is going to be the phase interface between solid and liquid, which in this case is labeled B. And which region includes the lowest pressures and the highest temperatures at which the phase of X is known? So low pressure and high temperature, you're talking about the gas phase, so that is going to be H. Oh, right. So there's quite a few different variations of this question. So I wanted to do another one. I think I did the harder conceptually ones first. So let's have a look at this one. If a sample of X is a liquid, in which region must the temperature and pressure be? So this is going to be the region that we've identified as the liquid region. So that is going to be region E on this particular variation of the diagram. If a sample of pure X is a mixture of solid, liquid, and gas, what point marks the temperature and pressure? So that is talking about the triple point here, which is point F as labeled on this diagram. Finally, which line must the temperature and pressure have crossed if a liquid sample is observed to boil? So if a liquid, you keep increasing the temperature and then you boil, you're crossing the liquid gas phase interface, which is labeled D on this diagram. Okay, so hopefully that helps you guys with interpreting how to answer these kind of questions.